How's it going? I'm Adam Wolf. I'm the CEO of Arable. We make this. I'll tell you about it in a minute. But first, I want to go back to the 90s. So 1995, I worked as an assistant farm advisor. So since you don't have my resume, this is after I worked at the campus hog barn, but before I worked as a research agronomist in Kazakhstan. And we had this farm advisor, just to give you a peek into what ag tech was like 20 years ago. He says, you only got to be right 70% of the time. And this guy is an encyclopedia, and you think, but in some ways, that's really what we want now, right? Take it back to something simple, a few words, definitely not graphs. But here's a graph. So if you go to any ag show now, you'll get the pitch, grow more with less. And sounds great, right? Best of luck with that. The thing is, Nebraska corn yields, just like they are almost any crop in any part of the US, they're basically at the theoretical max. So the real story of agriculture doesn't have to be with growing more per acre. It's more about growing more per person. So this guy here farmed 400 acres back in the 70s. Now he's farming 2,000 acres these days. And that's the average. There's large sprawling farms, obviously, 10,000, 20,000 acres. So this is what drives agricultural innovation over the last several generations. So just to unpack that a little bit, farms are like any other business. So just like all of the businesses you're in, their biggest issue is overcoming organizational complexity. So they've got land sprawled over all different parts of their territory. They're driving back and forth. They don't know who's doing what in which field, what they did when, how many trucks to send out to pick up all the berries that are coming up. So this, I'll tell you about the no trespassing story later, but the really came to a head when we ended up at Driscoll's. So I'm an agronomist. They say, you know what, we don't need you to tell us how to grow strawberries, but if you could tell us how many berries we have to sell, that would be huge. So just to put it in perspective, they tell us that bad forecasts cost the strawberry industry in California $10 million a week. So this is $500 million a year on the California's $2 billion strawberry industry. That's one crop in one state in one country on Earth. So Driscoll's is asking me, can you predict the future? And I said, kind of. Because, just to back up a little bit, NASA paid for my PhD literally so I could develop better crop forecasts from space. But the problem with doing this from space is you barely have a chance to see what's happening on the ground. And so I developed this, the Pulsepod. This is probably the 10th incarnation of it. I'll show it more to you later. And it was designed to be able to measure all these things close up so that it is visceral and local for the person who's making decisions. So just to give a peek into the landscape of this world, you've got this group of people who's making some kind of magic sensor. It plugs into this group of people who's got a data logger. Some other guy has a GPS unit. Some third person has a solar panel. And at the end of that, all this data just gets dumped in one haggis of a dashboard. And we found actually the real value here is in synthesizing the data so that it actually can say something tight and useful. So we make a device that measures across the weather, the plants, being able to look into the equipment. If you look at the landscape of agricultural technology today, basically as a rule where everybody zigs, we zag. So over here, this is the grow more with less category. This is improved agronomy and crop management in the Midwest. We're way up here. We're after risk mitigation operations for specialty crops. Not to say that there's not complementarity to move over here, but in general, really what's valuable and what's missing is tools for the specialty crops growers. Just like over here, where everybody's making dashboards, we actually don't have graphs. It's really, for us, much more about communication and coordination. Again, it's much more like a Slack, something that we all use. So we've got a bunch of beta coming out with a variety of different customers. If you want to talk to me more, here I am.
So where are you at in the stage of development, and how many of these are in the field at the moment?
Yeah, right now we're jumping on them, shattering them. So you know the Fitbit, so our mechanical engineers made sure that the Fitbit doesn't corrode when it sweats, make sure it doesn't bake in the sun and degrade. So right now we're going through all these tests with making sure this thing's not gonna go belly up in the field. April 4th, this all goes out to beta. So we got large Midwestern center pivot company. We've got berry companies out in California. Large insurer wants to be putting this in smallholder fields in Southern Africa. So that's the beta is all happening next month.
And have you got a crop or a specific value proposition for an individual farmer where you think the core proposition might be the launch proposition then?
You know, I get this question a lot. This thing is this, agriculture is very crop and geography specific. So if you talk to a rice grower in Calusa, he's worried about blast. If you talk to the berry growers in Salinas, 100 miles away, they don't care about blast. They're worried about capturing market upside. If you go to Nebraska, the center pivot guys, they want to know, when do I water? So really, we sit down here on the value chain where we make the best data there is. And we make best-in-class developer tools. And this empowers an exceptionally broad amount of analytics that tells the story to the person in a very local way. So agriculture is really about making it personal to that person. And then we do this other high-end thing that's around specialty crops forecasting, because that's what we do out in Princeton is run numbers. But anyhow.
So great landscaping, Adam. We've invested in several of those companies. What's your price to the grower, and how do you work that out?
The price to the grower, it's really staged out for, I guess, the feature set in the software. So the hardware is $500, so it's the cheapest thing that's buyable. And the real question is this data that's going to go into Encirca or somebody else's SaaS product? And there, it's kind of a bare metal price. Or are we doing something that's a little bit more high-end? Is this like we're actually telling the story about the data? Then that's a higher price. If we're doing forecasts, the Driscoll's story, they make something like $80,000 an acre. So what's the value for capturing upside for them? Thousands of dollars, right? So it's tiered according to how valuable is it to that farmer. And if it's on the low end, it's really somebody else's job, as far as I'm concerned. That's why we're working with all these other people to be able to take the data and personalize it to the customers they obviously know best.
Sorry, you have to apologize me for my ignorance. Can you explain what this product does again?
Absolutely. So, and this is something we do a lot because this never existed before, right? So this is a rain gauge, but beneath the rain gauge, there's a GPS. So this already is connecting it with satellite data, weather data, everything that's place-based. Out here, this is what makes it kind of like a satellite. So this is what's called a spectrometer. We're measuring light that's coming in 6 different spectral bands. So I can tell you, how quick is that crop growing? How much nutrients does it have? How much water does it have? Is it temperature stressed? We've got shortwave, long-wave radiation. Is it a clear sky? Is it a cloudy sky? Is it going to frost? Down here we've got crop temperature, right? So then we find out geez, growers, this is UK's largest lettuce producer. Can you tell us which of our lettuce is going to spoil in 3 days and which is going to spoil in 2 weeks? It has to do with how wet it was at harvest. So if you know the dew point of the crop, it's an exotic measurement, but it's there. So really, it's designed to be as data-rich as possible with a little bit of extensibility. I'm well overdue, so thank you very much.